Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about data warehousing. We will know about the concept of data warehousing, what is the components that we can attach within data warehousing. Finally, what is a warehousing schema we will discuss within column-oriented storage. We know that for large companies, when we store data, that stored data can be coming from diverse sources. Now, these diverse sources either can be from any of the industrial operation or the social operations or any other areas of this world. Now, when the diverse source is there to put in a single site, so it is a different and difficult task for the database designer to handle this situation. Now, how this diverse resources data we can put into a single schema. Now, the data that we are coming from, maybe for the large companies, they are using data that we purchase from different sources. Say for the credit bureaus, where they find the credit of the customer, that by comparing multiple companies that the customer is belonging to. Even if not like this, there is some service purchase customer. So they need to know about all the service that they can provide out of many levels of this society. So all this type of information need to be gathered into a single database, which becomes a real hodgepodge for which the database needs to handle. Now, whenever we want to find an information from this type of database, there are redundant data, might be there some inconsistency resist, and another problem. Another problem that is associated with this large and diverse resources of data, that each data that we are coming from different resources can be of different schema, even if sometimes they use different data type of model. Say for the corporate companies who uses to fetch data from different resources, now when they want to get the data on a statistical analytic on how a product is varying in different parts of this country, it will be different from what is the measure of that particular product in different shops. So they can be used by different categories of this online processing tool or even different data models to store this type of data. The third problem that is associated with this database is whenever we are storing this type of data, it belongs to the current data. That means the diverse source, that what data we are having now. But maybe we want to know that what was the data that we had passed on this information. So this all the problems can be solved by the term data warehousing. Data warehouse is a unified schema at a single site where we can process every diverse sources information into the single one with the unified schema. That means there will be only one model that can support to every type of decision or every type of data that can be accommodated inside it. That is why it is named as data warehousing. Now the data warehousing supported by decision support system and also data mining. That means we can mine through the data in this data warehousing and fetch particularly the data what we need based on some conditions. So it is not like that the processing will give only the data about an item. It will process the statistical analysis on this data warehousing, and it is absolutely important for the heuristic research of data, which is often needed for our business to evolve. Now we will talk about what are the components that we can have in this data warehousing. First, we can see that there are many data applications or from data which we can collect from diverse resources. After that, we are having it in this data warehousing. Finally, we are using this query processing or this analytical tool or the optimization tool by which we can gather the data in this data warehousing. So the data warehousing now have three parts. First is the collection of data, then warehouse the data, and finally then use it for the query process and optimization. Now how this data warehousing components can be connected with each other depends on several issues. We will discuss each of these issues now. First one is when and how to store the data. Now, when to store the data is becoming an important question about this data warehousing. Say for an enterprise which want to store data periodically or immediately after there is a change in the data. So there are two types of data that we can store. One is the source-driven data, another is in destination-driven data. When it is source-driven data, then we expect the sources to send or purchase by the particular employees, and they can be sent to this particular data warehouse about that data. It can be done in a second or it can be done overnight, like periodically. Whereas in contrast, if the database that is destination-driven data, it is storing in the data warehousing, that it constantly send the purchaser or that product informer that what data you can feed us in this data warehousing. So that is upon the data warehousing schema or the data model that it will use a source-driven data model or the destination-driven data model. Now, after the two-phase commit is completed, then we can store this data that we have collected from different data sources can be put to this data warehousing as to maintain the up-to-date data warehousing. Like this two-phase commit is the most safest protocol to give the data most up-to-date confirmation. But as we know that it is very expensive to produce this two-phase commit protocol, then often some data warehouses are slightly out of data, which is not a problem for the exemplifier or the company holder to hold on this data warehousing. The next issue that it covers is what schema to use. As we know that different types of data sources are stored in this data warehousing, we have previously described that different types of data types or even data model or different schemas can be of these data types. Now the data warehouse needs to store all the data based on a unified schema. That means first it needs to store and then search for the data type that can be allocated to a common data type with another data that is coming from another source. So there is a unified schema for storing the data warehousing where all the schemas are combined and compensated with some of the modification on which it can made to. The next issue that is data transformation and data cleansing. See, for what you mean by data cleansing is generally happen with where the data warehousing we are having a large amount of data based on the heuristic one, on the current one, and even if the one that we can calculate for the future. So there are some data which is erroneous. That means some names are misspelled, where some address and city combinations are misspelled. City names, say it is for Mumbai, it is written Mumbai. So this B and M, the pronunciation as well as this swapping becomes a spelling problem to this data warehousing. Now the data cleansing goes with that it just reconstructs the data based on some reasonable extent on which it can meet this type of corrections. Say the zip code and the postal code or well as the city and state combination can be corrected through a postal code book or any information that is available for the online. Now by this online processing or this OLAP tool that the data warehouse uses, we can fetch the data as much as correct it can be where we are storing the data into this data warehouse. The appropriate mixing of data and matching them with the tuple that the reasonable extent is known as fuzzy lookup, because we do not know that it is the exact information that the user is intended to store or not. We just correct the data as much as possible to a reasonable extent. Now this fuzzy lookup is always considered the most important one in this data warehousing when we are talking about data cleansing and data transformation. The next one is in March Purge application. So what is in March Purge? Say suppose that some names that belongs to different areas of this information, we can merge them together to have the shortening of data. That is deduplication, also named it, because we are not requiring the duplicating data to be stored into twice or as in redundant basis. Say for an example that a group of people lives in a single house. So other than sending a mailing address to it, we will send only a single mail to the address to the house, that all of these house owners, all of the livers of that house can get this message. So this is known as householding. That means we are grouping in basis of a particular attribute. See, data warehousing often uses the mailing services for advertisement, the credit information for a particular customer. So all this can belongs to this fuzzy lookup, where we can go for a reasonable extent and also merge the information based on a category on this attribute. Now, other than the cleansing, data may also be transformed in other forms. Say for the instance that the data that is coming from diverse sources, even if it is coming from the single sources, it can belong to different relation. Now, the data transformation include by joining these sets of data from the relations and to have a unified schema on it. See that we can use the DSS or some uses the appropriate particular type of this syntaxes like the condition box, the rectangles, the circles to join the data and to have a meaningful data flow from one data to another that belongs to a particular relation or a set of relations in a single site or different relations from different sources. The next one is how to propagate the updates. As we know that data warehouse must be up to date always as it belongs to this particular relation. So whenever there is an update in the relation, we should keep an update immediately if there is any data from the relation that is stored inside this data warehousing. Now it is just like this materialized views where we can store the data update on a particular relation or a part of the relation based on some conditions. So this is part of the view maintenance that we can provide to propagate the update immediately to the data warehouse when it is happening in this type of relation. Now the next issue that it solves is what data to summarize. We know that when the organization is storing some data or information, it is the raw data that the information is stored by the organization. That every possible attribute is there for storing a particular data for a particular information. Now when we are storing data in the online, it is not always possible to store this much large extent of data while having the transaction in this timeline. Now the online transaction system or OTS supports that we can summarize the data, and even if from the summarization of data we can have the query that we can fetch to the direct relation. Say for an example that for every sales information on a product or the tuple that contains the information, we are only having the total sale item that is related to the item name. So now we can have the item name and also the sales of that information. We know that we often need to know not a particular information but a heuristic information when we are studying it from an online one. Now the online processing system helps us to get this summarized data as not only the shortening of data but also a fast access to this data. Say for an example when there are multiple or hundreds and thousands of tuples in a database and we want to fetch a particular attribute, then it is absolutely important to summarize the data based on some condition on which the DSS is happening. That means we first need to know that what site we are using, and based on that demand we can categorize our summarization on that particular relation. So these are the issues that we can cover by this data warehousing. Now, how can we define this warehouse schema? Now, before going to warehouse schema, the different steps of this data warehouse performance is known as ETL, that is extract, transformation, load. So what is an extraction? That is the collection of data from diverse resources and fetch the data to be stored in the database. Transformation and cleansing, cleans the data and transform the data to some way and stored to the database. Now finally we need to load the data into the data warehouse from that particular database. Now while loading the data into the data warehouse, we must see that the different types of data belongs to different types of schemas. Say for an instance, when we are having that which applications to be registered in an university, which items are purchased in a particular shops on that particular country, then all this type of information are having large quantities of attributes associated with it. So when such relation exists in our data warehouse, that is known as a fact table or fact relation, where we can have a multi-dimensional attribute that can goes with the store of dimension attribute as well as measure attribute. Say for if we were taking an example of a salesperson, then we can say that for the sales oriented details, we can have the customer ID, the product ID, the sale ID of a customer, and we can store that in the particular inventory sales. Now the relation that keeps the dimension attributes, which gives the dimension, that means what data to use by using this product ID, customer ID, sales ID, and the measure attributes are the price and quantity on that particular item, which we can measure on some dimensional attribute. So these two attributes are stored into a fact table. So a fact table is a table that contains tuple that belongs to a fact that we can fetch from a data warehouse. Now the associated with fact table, there are multi-dimensional attribute, and each of the dimensional attribute can go to another dimension table which is attached to this fact table. Now for the dimensional table, they have a shorter key that is associated with the fact table and represents as a foreign key to this dimension table to be attached as a schema. Say for an instance, if there is a sales table that we have described, we have the product ID, customer ID, sales ID, price and quantity. Now the price and quantity are my measure attributes and the first three are my dimension attributes, where the product ID serves as the product information table and another foreign key to the product information table. As we can see that the customer ID goes and sees with a foreign key to the customer table, which gives the information to the customer. So the sales or the fact table is in the middle, and all these dimensional attributes are surrounding it just like a star. So that is why this type of schema is known as a star schema. Whereas say for this quantity table or the order ID table, which is going to the foreign key in this order information, and in this order information table we again has a manufacturer ID which is in dimension, which can be served as a foreign key to the manufacturer table to tell us about the manufacturing on a data. Now this type of schema is known as Snowflake schema because there is a star schema, and after that from the star there is also some star, so it is looking like a snowflakes. Now we know when we are storing this customer complaint details, that will be stored in a different types of database, and when we are storing that the manufacturing problem or what are the manufacturing issues that we are having, that will be stored in a different type of database. Now not only this multi-dimension attribute and measure attribute, we need to take care of different types of data that we are fetching from different types of information. And then this data warehouse using either the star schema or this type of schema that is known as a snowflake schema need to be stored in this data warehouse in a unified model. Now let us know about this column oriented storage. Till now, we have discussed that as database application, we have a relation. Inside a relation, we have attributes, and a tuple gives us a record on each of the attributes. That means, say for an instructor relation, if there are attributes like instructor, ID, name, department and salary, then if we combine all the attributes in a single row, then it gives an fact on that instructor. Say for the instructor 101 ID, name Kim, belongs to physics department, gets a salary of 50,000. So there is a fact that gives us as a row of this particular relation. So this is known as row oriented storage. But right now we are talking about column-oriented storage. That means every attribute of a particular relation will be stored in a different file. So now my files become the containing information on an attribute, not a tuple. That means now we are gathering a fact on which a particular quantity can be compared on different items. So now column-oriented storage have some two advantages based on this row-oriented storage. The first one is in the column-oriented storage, it is better and faster access if we want to access only a fewer attributes with a large number of attributes of relation. Now we do not want to not only pre-process the data but also fetch the data from the disk of the memory to the main memory, where it is extremely costly to have the CPU cycles, where it will be wasted if we have an undesired attribute and at least thousands of undesired attributes as a part of the tuple that we are fetching. So if the data is stored in a row-oriented manner, then we must fetch the tuples from this database. But if it is stored in a column-oriented manner, then we can see that only the type of the data or the attribute of the data that we can fetch, we will only pre-process that and fetch the data. That will reduce the CPU cycles and as well as the computation time. Now say for an example, for a relation R, if it is an A attribute that belongs to the ith tuple, then we can store it into the I information table, where we can store and access this I-1 lookups as an index number or the offset by which we can reach this ith tuple data on that particular attribute. Now another advantage of this column oriented is that storing the same type of data in a particular file just increases the effectiveness of the data. Now also the problem of this disk storage that we can have on side of a row information can be sorted out into this column oriented information storage. Now we can squeeze the disk storage as much as possible because we are having only a particular type of data. But one trade-off on this column-oriented orientation is when there are multiple attributes and there are many data that we can attach with each other, there will be multiple IOs associated with it. So the increase of IO cost will be associated with an column-oriented storage. So for this column-oriented storage, many of the applications avoid this because of this trade-off, and now we can store the row-oriented information in the database. But also this column-oriented storage is becoming popular nowadays among many of the databases because it can serve as a purposeful nature in a data warehousing. Whether we are not using in a database application or not, it is very popular when we are having the data warehousing, where we can have a statistical analysis on data when this column-oriented storage becomes extremely useful. Sybase IQ is one of the applications that uses this column-oriented storage at the first one was to introduce this concept. But nowadays, not only this Sybase IQ, there are many applications belonging to the educational institute, the manufacturer companies using this column-oriented storage as a purpose to solve the data warehousing. So in this way, data warehouse helps us not only to store the diverse information provided in a unified schema, and that we can perform an heuristic data research on it, and finally we can have an DSS supported by this data warehousing. So thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.